All right, so in our previous videos, we talked about um, what it meant for power series to converge. Uh, Remember when we talk about power series converging, the set of values which converges is called the interval of convergence. The distance from the center that it converges for is called the radius of convergence. So usually what we'll do in these problems is we'll actually be finding this radius of convergence first. And then we'll have to test the endpoints of our intervals because what we'll use is either the ratio or root test. And basically we'll be looking at the radius, see how big it is. Often that'll lead to r is less than something, all right, in which case we have limited convergence, and then we'll test our endpoints to get our interval to see whether the endpoints are included or excluded. Of course, we get lucky and find out R works for everything, right? Then we don't have to bother checking our endpoints. And of course, if we get R equals 0, again, it only converges at 0. There won't be any endpoints to check either. But when we're dealing with this situation where we find that the absolute value is less than a number, then we'll have to decide whether the endpoints get included or not. So we check those separately. We'll see how that works when we get to some of these examples. So again, we want to test convergence. We're testing actually for absolute convergence. And that allows us to use either our ratio or root test. Since we're involving a factorial here, the ratio test is great to bring about when you have factorials. Root test, not so great on factorials. So because I have a factorial here, pretty straightforward, I definitely need to use the root test, or ratio test, sorry. So we use our ratio test. So remember the way that works. We're going to be looking at the limit of the ratio. So I'm actually start computing that ratio first. So the k plus 1 term, so that'll be x minus 1 to the k plus 1 over k plus 1 factorial. Again, that's absolute value of all that, divided by absolute value, x minus 1 to the k, over k factorial. And then we want to simplify that. So this would be, put it all under one big absolute value. X minus 1 to the k go on top. Because we're dividing by that, the k factorial will also go on top. And then the k plus 1 factorial is in the bottom. And then the x minus 1 to the k will be on the bottom. So this is x minus k 1 to the k plus 1, sorry. That should have been k factorial, and then x minus 1 to the k on the bottom. Okay, and then we just need to go through and simplify. So first things first, we have x minus 1 to the k. That'll cancel with the x minus 1 to the k in the bottom. And that's just going to leave us with an absolute value of x minus 1 to the first power. All right, and then in the bottom here, we're going to have k factorial over k plus 1 factorial. Remember the k plus 1 factorial. We can rewrite that as k plus 1 times k factorial. And so that k factorial will cancel out from both top and bottom. And since k plus 1 is always going to be a positive number, I can drop the absolute value on that part. And I just have k plus 1. Okay. And so that's the expression I'm going to be dealing with. And now with the ratio test, we want to look at the limit as k goes to infinity. We look at the limit as k goes to infinity. Not as x goes to infinity, but as k goes to infinity. X is again just a number. So x minus 1, the absolute value of x minus 1 is just going to be a number. But as k goes to infinity, this thing, the denominator, will go to infinity. X minus 1 is just for given. And here I said it. I said k, but I wrote x. Got to watch out for doing that. Bad habit of doing that sometimes. So as k goes to infinity, k plus 1 is going to be infinity. X minus 1 is going to be some number. Absolute value of x minus 1 is going to be some number. If you have some number divided by infinity, that actually goes to 0. That actually goes to 0. Now for this to converge, the stuff needs to be less than 1. But since for all values of x, this goes to 0, which is less than 1, since that happens for all values of x, we actually know that it converges for all x. So it turns out this power series is actually going to converge for all values of x. And so that means the radius of convergence is infinity. And therefore it converges from negative infinity to infinity. Okay. And of course, in that case, we're never including the endpoints because infinity is not a number. And so here we have an example where it turns out this infinite series will actually converge no matter what number we put in for x. No matter what number we put in for x. Okay? So that's actually kind of a pretty cool idea there. That is always going to converge. Always going to converge.